So far we have talked about configurable LCP options to meet specific WAN connections requirements. PPP may also include some of the following LCP options. You have authentication. That's the two authentication choices are password authentication protocol, which is PAP, or challenge handshake authentication protocol, or CHAP. We have compression. It increases the effective throughput on PPP connections by reducing the amount of data in the frame that must travel across your link. The protocol decompresses the frame at its destination, so it compresses it when it leaves and it uncompresses it when it gets there. So two compression protocols available with Cisco routers are Stacker and Predictor. And then we also have error detection, and that identifies fault conditions. The quality and magic number options help ensure a reliable, loop-free data link, and the magic number field helps in detecting links that are in a looped back condition. Magic numbers are generated randomly at each end of the connection, and these magic numbers have nothing to do with our subnetting magic numbers. We have PPP callback. PPP callback is used to enhance security. With this LCP option, your Cisco router can act as a callback client or a callback server, and the client makes the initial call, requests that the server call it back, and terminates its initial call. The callback router answers the initial call and makes the return call to the client based on its configuration statements. The command is PPP callback, either accept or request. The Multilink is an alternative. It provides load balancing over the router interfaces that PPP uses. And Multilink PPP provides a method for spreading traffic across multiple physical WAN links while providing packet fragmentation and reassembly. Your proper sequencing, multi-vendor interoperability, and load balancing on inbound and outbound traffic. To configure our PPP, here we have it set up on two different routers. With this router, so the command that we're going to use is we go into our config T, we go into our interface, so interface serial, whichever serial interface you're going into, and then encapsulation PPP. With encapsulation PPP, there are no arguments, so it's just encapsulation PPP. Keep in mind that PPP is not configured on a Cisco router. The default encapsulation for serial interfaces is HDLC. Okay, so if you don't set it up as PPP, it's going to default to HDLC with your Cisco routers. Point-to-point software. Compression on serial interfaces can be configured after your PPP encapsulation is enabled. So after you do encapsulation PPP, your next command would either be compress predictor or compress static. Predictor specifies that a predictor compression algorithm will be used, and stack specifies that stacker or LZS compression algorithm will be used. So it determines which of the two algorithms we will use for compression. Remember that the PPP quality with LCP provides an optional link for quality determination phase, and in this phase your LCP tests the link to determine whether the link quality is sufficient to use at a layer 3 protocol. And the PPP quality percentage command ensures that the link meets the quality requirement set, otherwise the link will be closed down. So that command is PPP quality percentage, and the percentage is a number from 1 to 100. Use the no PPP quality command to disable the LQM. The Multilink PPP, also referred to as MP, MPPP, MLP, or Multilink, provides us with a method for spreading traffic across multiple physical WAN links. With the multiple PPP, it also provides packet fragmentation and reassembly, proper sequencing, multi-vendor interoperability, meaning we can operate between different vendors, and load balancing on inbound and outbound traffic. The Multilink PPP allows packets to be fragmented and sends these fragments simultaneously over multiple point-to-point links to the same remote address, so it's all headed in the right direction. The multiple physical links come up in response to a user-defined load threshold, and MPPP can measure the load on just inbound traffic or on just outbound traffic, but not on the combined load of both. To configure MPP, it requires two steps. So we've got to create our multi-link bundle, and the interface multi-link number command creates the multi-link interface. So here in the example you see for router 1, it says interface multi-link 1. We have our IPv4 address. We have an IPv6 address. Then we tell it that it is PPP Multilink. And then we tell it to PPP Multilink Group 1. And the same thing is set up on router 4 here, so that those portions are in agreement. They're on the same network for each multi-link group, but the multi-link groups can go across different serial interfaces, as you see here. We can verify our PPP configurations by doing either the show interface serial, or show PPP multilink. So here is the show interface serial. We see that our serial is up and up. We see that it is encapsulated with PPP. The LCP is open. It also shows you that it has open the IPCP, IPv6CP, CCP, CDPCP, and loopback are not set. Okay, so that shows you what the show interface serial is going to give you. If we do the show PPP multilink, the output indicates that the interface multilink 1, the host names of both the local and remote endpoints, and the serial interface assigned to the multilink bundle. So here we see multilink 1. It says that the remote end discriminator is router 4. Our local input is router 3. And our member links, we have two that are active, serial 011 and serial 010. With PPP, it's going to define an extensible LCP that allows negotiation of an authentication protocol for authenticating its peer before allowing network layer protocols to transmit over that link. The RFC 1334 defines two protocols for authentication, that is PAP and CHAP, and that's what we're showing here in this diagram. PAP is very basic two-way process. There's no encryption. The username and password are sent in plain text. If it's accepted, the connection's allowed. CHAP is a little bit more secure than PAP. It involves a three-way exchange of shared secrets. The authentication phase of PPP session is optional, and if it's used, the peer is authenticated after LCP establishes the link and chooses the authentication protocol. If it's used, authentication takes place between the network layer protocol configuration phases before they begin. The authentication options require that the calling side of the link enter authentication information, and this helps to ensure that the user has the permission of the network administrator to make the call. Peer routers exchange authentication messages. One of the many features of the PPP is that it performs our layer 2 authentication. Here we're going to go through what it takes to initiate PAP. What happens is that R1 sends its PAP username and password, in this instance to router 3. Router 3 is going to evaluate router 1's username and password against its local database. If it matches, it accepts the connection. If it doesn't, it's going to reject the connection. Keep in mind that this username and password are in plain text, so it's not exactly the most secure authentication method. However, it is used in several different environments. One is a large installed base of client applications that do not support CHAP. If the incompatibilities between different vendors, implementations of CHAP, or situations where a plain text password must be available to simulate a login at the remote host. So that's where that would come into play. When we do CHAP, or the Challenge Handshake Authentication Protocol, Router 3 is going to start this one out. Router 3 initiates the three-way handshake and sends a challenge message to Router 1. Router 1 is then going to respond to Router 3's CHAP challenge by sending its CHAP username and a hash value that's based on the CHAP password. Okay, so CHAP provides protection against playback attack by using a variable challenge value that's unique and unpredictable. And because the challenge is unique and random, the resulting hash value is also unique and random. The use of a repeated challenge limits the time of exposure to any single attack, and your local router or third-party authentication server is in control of the frequency and timing of these challenges. So once the router 1 sends back its username and its hash value, then using the username and password that R1 sent it, R3 compares it to the calculated hash value with one that was sent to R1. So then it accepts it, it acknowledges that it was correct, or it will reject it if it does not meet that hash. So the flow of PPP encapsulation and authentication proceeds somewhat like this. Let's just assume we're talking about router 1. It's established an authenticated PPP CHAP connection with router 2. So the first step is that router 1 initially negotiates the link connection using LCP with router 2, and the two systems agree to use CHAP authentication. The next step is that router 2 generates an ID and a random number and sends that to its user and its username as a CHAP challenge to router 1. Next, router 1 uses the username in the challenge, that's from router 2, and it cross-references with the local database to find its associated password. Router 1 then generates a unique MD5 hash number using R2's username, ID, random number, and the shared secret password. Next, router 1 then sends the challenge ID, the hashed value, and its username, that's router 1's username, to router 2. Next, router 2 generates its own hash value using the ID, the shared secret password, and the random number it originally sent to router 1. Then we get to step 6, and at that time router 2 compares its hash value with the hash value sent by router 1. If the values are the same, router 2 sends a link established response to router 1. If the authentication fails, a CHAP failure packet is built from the following components. 04 is the CHAP failure message type. You have the ID, it's copied from the response packet, and then authentication failed or some similar text, which is meant to be user readable explanation. Now, to specify the order in which CHAP or PAP protocols are requested on the interface, we use the PPP Authentication Interface Configuration command that's shown here. After you've enabled CHAP or PAP authentication on both the local router, router requires the remote device to prove its identity before it allows traffic to flow. And this is done as follows. PAP, the authentication requires the remote device to send a username and password to be checked against a matching entry in the local username database or in the remote Taxes Plus database. With CHAP, you have authentication sends a challenge to the remote device. The remote device must encrypt the challenge value with the shared secret and return the encrypted value and its name to the local router in response message. Then your local router uses the name of the remote device to look up the appropriate secret in the local user or remote Taxes Plus database. It uses the lookup secret to encrypt the original challenge and verify the encrypted value match. Either PAP or CHAP or both can be enabled. If both methods are enabled, the first method specified is requested during link negotiation. If the peer suggests using the second method or simply refuses the first method, the second method should be tried. On some remote devices support CHAP only, and some support only PAP. The order in which you specify the methods is based on your concerns about security. When you configure your PPP authentication, you have to set it up on both routers. So here we see that for router 1, we set up the username. For router 2, the password. And then we've also got that the PPP authentication is PAP. The PPP PAP is sent the username R1 and the password. And then we do the same thing in reverse on router 2. We give it router 1's name and password, and we send it the username for router 2 and its password. Here's an example of how we're going to configure CHAP. On router 1, we give the username and the password, and then we do PPP Authentication CHAP. And that way it knows it has the three-way handshake that has to be set up.